So today's lesson is 3-1 and it's rational numbers. So the first thing I want to do is I want to watch this video together, okay? So you don't have to take notes on it. All you have to do is watch it.
Lesson with Mr. Joe. In this video, I'm going to cover what rational numbers are. Now, simply put, rational numbers are numbers that can be written as a fraction, specifically a fraction of two integers. So the numerator must be an integer and the denominator must be an integer. Now, fractions can be written as decimals. So anything in decimal form that either terminates, so cuts off, or repeats, so continues on forever in some type of pattern, those are rational numbers. This may all seem confusing at first, but as we go through our examples, this will all make a lot more sense. So any number that can be written as a fraction of two integers, so the numerator must be an integer and the denominator must be an integer, that's going to be a rational number. Now remember, integers include positive and negative numbers and zero. Decimals and fractions are not included. Now, one thing I do want to mention, the denominator cannot be zero because that will give us a value that is undefined. That's why zero is crossed off for the denominator. So something to keep in mind. Let's jump into our examples, starting with number 1, where we have 6. So we have a whole number here. Can we write 6 as a fraction of two integers? Yes. For example, we can write 6 over 1. That equals 6. Or 12 over 2. That equals 6. 36 over 6. That equals 6. All of those examples equal 6. So 6 can be written as a fraction of two integers. So it's a rational number. And all whole numbers are going to be rational. What about negative 6? What about a negative number? Can we write this as a fraction of two integers? Yes. Negative 6 over 1 equals negative 6. Or negative 18 over 3 equals negative 6. So negative 6 is a rational number as well. Let's move on to number 2, where we have a decimal, 7/10. Is this rational? Well, it is a terminating decimal. It cuts off. So right away, we can see that this is rational. But can it be written as a fraction of two integers? Yes, 7/10 can be written as 7 over 10. That equals 7/10. Or 21 over 30 equals 7/10. Or even 70 over 100 equals 7/10.
So now, you guys, we're going to fill in our vocabulary, okay? You have your worksheet. And our first definition is a rational number. So a rational number is any number that can be written in the form A over B, where A and B are integers, positive or negatives, and B cannot be equal to 0, okay? And the guy in the video already told you why, because it would be undefined if we have 0 in the denominator. They can be written as a fraction, as a decimal, or as a percent. Terminating decimal. A terminating decimal, the decimal places in the quotient end with zeros. They end with zeros. So, for example, if I had 0.200, so those, they end in zeros. If you can add as many zeros as you want, it's still going to be a terminating zero, because do I need these trailing zeros? No, we don't need those trailing zeros. A repeating decimal is one or more digits in the quotients repeat. So that looks like this. Let me put an example in here too. So a repeating decimal looks like this. So let's see, 0.3 232 dot dot dot. Okay, so that is a repeating decimal, or 0.777 dot dot dot. Is everybody with me? So sometimes you'll see the dot dot dot, but sometimes you'll see bar notation. Okay, sometimes you'll see bar notation. So if, for example, these two repeating decimals up top, if I wanted to use bar notation for that, so here I would write 0.7 with a bar on top like that. Is everybody with me? Okay? That indicates that the 7 repeats. Okay? What repeats in the other decimal? The other repeating decimal. What repeats there? In the other one? What repeats in the other one? Yeah, 3, 2, 3, 2, 3, 2. So the 3 and the 2 repeat, right, in that order. So we would write 0.32 with the bar notation over the 3 and the 2. Please make sure you write down those examples that I gave for your vocabulary. That will be helpful. So for example 1 and example 2, we are going to write the mixed number as a decimal. Okay? So there are several different ways that we can do this. And last year, I talked to you about changing them to improper fractions and then doing the division. Okay? But today, I'm going to show you this. Okay? This is the whole number part, right? That's the whole number part. Can't I just bring that down to the decimal and put it in the whole number part of the decimal? Yeah. So we're just going to bring that whole number down, and that's going to go in the decimal part. Okay? Or you can put it on the side if you want to. Okay? And then, so that's the decimal part. And so this says 1 and 7/18, right? 1 and 7/18. When you hear the word and, that signifies that you need a what? You need a decimal. So when you hear the word and, that means decimal, right? So here, 1 and, so we're going to put a decimal there. 1 and now we want 7/18. We want to change that to a decimal. Do you guys remember how to do it? What does this fraction bar mean? Yeah, that fraction bar means divide, right? So that means you're going to divide in your calculator 7 divided by 18, okay? So you're going to write 7, you're going to type in 7 divided by 18, and what do you get? 7 divided by 18, and that's going to give you 0.3888888 repeating, right? So this is equal to 1.3888 repeating. Dot dot dot. Is everybody clear? What repeats in this number? The 8. So can anybody tell me how to write this with bar notation? Raise your hand. All right, so this one, if I'm going to write bar notation, this is going to be 1.38 with the bar over the 8. Is everybody clear? For example 2, we have -3 and 111. Now, when we're doing negatives, it's no different. It's no different. We have a an integer part, right? We have an integer part, and that integer part is -3. Okay? So we're just going to bring that down. Okay? So go ahead and bring that down. So that -3 comes down. And then, what am I going to do with the 111th? We're just going to divide. How am I going to type it into my calculator? Albus? 1 divided by 11. All right, so this is what we got, 0.090909. So now we're going to put that in our decimal. So we're going to write -3.090909. 0.0909 dot dot dot. Now, what part repeats? What part repeats? The 0 and the 9. So, how am I going to write this with bar notation? You put the bar over the 0 and the 9. Very good. So, we're going to write equals negative 3.09 with the bar over the 0 and the 9. Is everybody clear? So now we want to write repeating decimals as fractions and percents. Now, you guys, this is very involved, okay? There are a lot of steps in this, okay? In order to change a repeating decimal to a fraction, we got to do some subtraction. We need to do some canceling out. We have to do all kinds of stuff, okay? So, the first thing we want to do is we want to say to ourselves, what part repeats here? So we want to ask ourselves, how many digits repeat? Well, how many digits up here repeat? One. One repeats, right? So if in decimal terms, if I have one number repeating, that's going to be the tenths place. Is everybody with me? Because one number is a tenth, two numbers is the hundredths, three numbers is the thousands, right? So here we are going to, what we need to do is we need to multiply this number by 10, okay? This is equal, let's just call this equal to n, okay? Now, if we multiply that number times 10, we're doing 10 times n, right? 10 times n. And when you put 2.83 times 10, you got 28.3, right? Is everybody with me? So you've got a negative, right? But we're not going to deal with the negative. So we have 28.3, but doesn't the 3 still repeat? Okay. So 3, dot, dot, dot. Is everybody with me? Okay. Now, so now we want to subtract n, but we don't want it. But we're not looking at the negative. Okay. So we want to subtract n. You with me? What's n? What's n? 2.83 repeating, right? Okay, so on one side over here, we're going to subtract n, right? And then on the other side, we're going to subtract n. That's 2 minus 2.833 repeating. What's 10n minus n? Because remember, there's a 1 in front of here. What's 10n minus 1n? 9n, right? So this is going to be 9n. You with me? Now we have to subtract 28.3 repeating minus 2.83 repeating. Now, if you look at this, doesn't this part, this 3 dot 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 and this 3 dot dot dot, can those cancel out? Yeah, because that's like saying 2 minus 2 is 0, right? This is saying 3 repeating minus 3 repeating, that's equal to 0, so that cancels out, right? Is everybody with me? So we're just going to draw a line through that and that. So that cancels out. So now we've got 28.3 minus 2.8. And that's going to give me 25.5. So bear with me. Now, you guys know how to do this, right? 9 times n is equal to 25.5. How do I get that n by itself? Okay, so here, you guys, we're going to divide by 9. Okay, so we're going to divide, I'm sorry, not divide by n, divide by 9. So we're going to divide by 9 on both sides. So those 9's cancel. And n is equal to, let's see, let's put it in the calculator. Where's my calculator? So we've got 25.5 divided by 9. Oh, that is our fraction. That's our fraction, 25.5 divided by 9. So we don't want decimals in our fraction, so we need to move this decimal to the right, and we need to move another decimal to the right. What do I do with that loop right there? Add a 0. So this is going to say, and this is our fraction, 255 over 90. This is our fraction. And now we can change that to a mixed number. You with me? Okay? So how many times does 90 go into 255? All right, so 90 goes into 255 2 times with 75 left over. So this is going to be 2 and 75/90. And there's my fraction. Is everybody with me? And of course, can I simplify that? Yeah, I can divide both of those by 5. 2. So here we're dividing by 3 again. We're simplifying some more. So we get 2 and 5, 6. Is everybody with me? All right, so example 4, the first thing we want to do is we want to call this n. So this is equal to n. Okay? So n is 27272727 repeating. If we have one number repeating, then we have to multiply that n times 10. And that's because 10, that's the 10th place, right? If we have 2 numbers repeating, what place value is 2 numbers? Right? So then 2 numbers is 100th place, right? So you'd have to multiply times 100. If we had 3 numbers repeating, what do you think we would multiply times? 1,000, because that would be in the thousands place. Is everybody with me? Okay, so for this example 4, because we have 2 numbers repeating, we have to multiply times 100. Very good. We're going to multiply times 100. So n times 100. So we have 100. Oops. We have 100n. And then in your calculator, I would like for you to type in 0.2727227, and then multiply that times 100, because that's what n is, right? What do you get? 27.272727 repeating, right? Is everybody with me? So when I multiply both sides by 100, we get 27.2727 repeating. Okay, so this is, I put the n equals on the other side just so your n's are on the same side. Okay, the next step is that we need to subtract n. Okay, so on one side we're going to subtract n here, and then on the other side we're going to subtract the numerical version of n. What's the numerical version of n? We're going to subtract the numerical form of n on both sides, on this second side. So that's going to be minus 0.2727 ... repeating. What do you get when you subtract something minus itself, you get 0, right? So on this side over here, not that, over here, what's this going to be equal to? 0, right? So can I just cancel it out? Can I just draw a line through it? Okay, so this cancels out to 0. So now, on that side, we just have 27 minus 0, which is what? 27. So now we have 27 on this side. And then on the other side, we have 100n minus n. What's that going to be? Okay. Don't forget, you guys, there's a 1 in front of that n. So what's 100n minus 1n? 99n. Is everybody with me? So this is going to be 99n. This says 99 times n is equal to 27. How do I get the n by itself? If it says 99 times n, how do I get the n by itself? So here, we're going to divide on both sides by 99. Divide on both sides by 99. So, this is 99 divided by 99. That equals, no, 1, right? So this equal to 1. So 1 times n is n. And then here we have 27 99ths, right? Can I simplify 27 99ths? What can I divide by? We could do 3. We could do better than 3. 9. 9. So let's divide here by 9 and divide here by 9. Okay? And so now this is going to be 27 divided by 9 is 3. And 99 divided by 9 is 11. Is everybody clear? Everybody got that? So 0.27, repeating, as a fraction is 3/11. So now the percent, you guys, for a percent, we've got 0.272727 repeating, right? How do I change a decimal to a percent? Times it by 100, or just move the decimal 2 places to the right, just like that, right? So we're going to, and now my decimal is right there. So this is going to give me 27.272727, right? But what is 272727? What's that fraction? What's that fraction? 3/11. So the percent is 27 and 3/11%. All right, example 5 says, during a recent basketball season, a team made 38 out of 88 field goals they attempted. What percentage of the shots did they make? Write your answer as a decimal and as a percent to the nearest percent. All right, yep, so we're going to change this to football because that's field goal. Okay, so what is important here? So they made 38 out of 88 field goals, right? Now, how do I write 38 out of 88 as a fraction? So we're going to write 38 over 88. There's my fraction. Write that down. How do I change that to a decimal? We're going to divide, because remember, that fraction bar means divide. So in your calculator, what are you going to type? 38 divided by 88. Go ahead and do it. All right, so that's what we got in our calculator, okay? Now, that's my decimal. How do I write that using bar notation? We're going to write, we're going to write 0.4318 with bar notation over the 1 and the 8. Okay? And now we want to change this to a percent. Decimal to percent. If I have decimal to percent, which way do I move the decimal? To the right. How many places? 2 places. So this is going to be a loop right there. And now my percent is going to be what? So my percent now is 43.18, repeating percent. Is everybody with me? Okay, now we want to round to the nearest percent. Round to the nearest percent. So that means this number, we're rounding to the nearest percent, and so the 1 tells me what to do. Stays the same. Very good. So this, when I round it and you guys see the squiggly equal sign, that means is approximately equal to. Okay? So this is going to be 43%.